but that was a funny thing to say. So, Carl, nice to meet you. Thank you very much for the time
Thank you, Thomas.
to make this interview happen. Um, I will tell you, the thing is that this podcast or this project is a very personal thing. I've been always very curious about how the world and the universe work, and that is why this podcast called Beaulik is a mix of technology, beautifulness, art, science, and etc. So, um, in that regard, um, the first question, of course, I have for you is, what does an astrophysicist do? I think that is it would be I don't know if there is a definition or a simple definition of that.
So thank you. Before I try to answer your very all-encompassing question, which is quite a cool question. I want to thank you very much for initiating this awesome podcast, and I think it's very cool that you have this podcast to let general public know about things that fascinate you personally, and also things that might inspire young people, different audiences, and really connect across the pond. So right now you're connecting Chile with Luxembourg, which is very cool, and and also for me this is my first podcast. So that you're hosting me on your podcast, thank you. That this is my first participation in the podcast. So thank you. Physicists do well. That's quite a encompassing question. So I think if we look at the word astrophysics, then astro is like stars, and physics is the study of physics, and physics is connected to other sciences because all of this used to be philosophies. So back in the day, there wasn't separate chemistry or biology or physics or. So they were all united in philosophy and discussions like this. So like coffee conversations, but perhaps over tea or over other beverages, local beverages around the world. So, astrophysics. Also cosmologists. Cosmologists study, let's say, the beginnings of the universe, trying to explain everything, Big Bang afterwards, which goes into like celestial dynamics, orbits, planetary dynamics, the sun. The sun is something that I focus on in my research here at the University of Luxembourg. Perhaps this is a good point to introduce maybe myself in a personal capacity with the work that I do. So I'm a postdoctoral researcher. Postdoctoral researcher means after my PhD, I've continued doing research, and I am a researcher at the University of Luxembourg, SNT. SNT is the Center for Security, Reliability, and Trust, and that's at the University of Luxembourg. And the focus of SNT is to have public-private partnerships, and so we work with industrial partners on their challenges. So I work in my capacity on this project with a startup company called Mission Space. And their core business is space weather. Space weather is the interaction, how our sun, how our local star, the sun, affects the environment, the geomagnetic environment, to be a little bit more detailed, of the Earth. And this affects the satellites that are orbiting around, which means all of modern technology. Anything that's to do with sending signals from space to Earth and from Earth to space, those are assets of all of humanity, and it's important. Just as a weather forecaster predicts thunderstorms, and when there's inclement weather, when there's rain or hail or hurricanes, there is kind of analogs of this with very high energy particles that are coming from the sun, also a solar wind emanating from the sun, and also these large magnetized plasma clouds, which the sun kind of shoots off into space. And when that large plasma cloud, which as an analogy, think of it as the Earth being a pebble on the beach, and then you have a tidal wave coming. That's how such a storm or cloud looks like. It's an enormous cloud that engulfs the Earth when it's in the direction of the Earth. So kind of the Earth has to be in the right place at the right time for this cloud to actually have an effect. And then there are various interactions that happen. And thankfully, our Earth, our home planet, has a magnetic field, and that acts as a shield to protect us. But through various interactions, there are particles that do make it through this shield and cause the beautiful auroras that we see in the north and the south, so aurora borealis, aurora australis. But also they interfere with modern technology. So, for instance, with GNSS, GPS, when anyone driving a car relying on GPS or GNSS for navigation, ships, precision drilling under the sea. Sorry for maybe going on about space weather, but that's a topic that I work in presently, and
Awesome.
thank you. Yeah, well. I think, as you were saying, when you wake up in the morning and you're happy and you go to work and you do something that you like, you can say awesome for all these things, because I think every work has kind of a non-mundane or kind of a deeper component, which makes the work very interesting and meaningful. Also, I might tend to just go off on tangents. Please.
That's the whole point of this podcast, is to go over the tangents, and it's not something I have some questions for you, but we can go wherever the conversation goes, so don't worry about it. And just I have some question about something very domestic, I think. That is, how did you get to be an astrophysicist? What happened to you that you became interested in everything that you have recently told me?
Yes, thank you so much. Yes, so there's astrophysics, there's cosmology, and there's astronomy also. So those are the three very closely related fields. And basically, I started off being interested in physics and mathematics. And these are part of the STEM subjects, science, technology, mathematics, also arts. Some people say STEAM as well. So arts, economics, if I'm not mistaken, or environment. I forgot what the E, I have to look it up. I was interested in how we can use our thoughts as thought experiments, and also the tools of mathematics and physics to understand behind what requires, let's say, other instruments to see. So with our five senses, we perceive the world, we interact with it. And we all know that the world is much, much bigger than that, right? So us to be able to peer inside of that, we need new technologies that probe the electromagnetic spectrum, that tell us about, what are the building blocks of the universe, fundamental forces. We know of strong force, the weak force, gravity, electromagnetism, dark matter, of dark energy. We know of those things, yet our knowledge is also, still a ways to go. So as a scientist, one is always, revising, updating knowledge, seeing if everything that is previously agreed upon by the community as being factual, as being, foundational, if that's still is in agreement with further theories that come around. There are theories that are... So a theory, I think, is something that can be disproved. It's a theory. It's widely accepted because it describes a lot of the phenomena that we see. And a law of a physical law is something that is been established. It is a fundamental principle that operates in the reality that we are aware of. So, law of gravity, right? The 1/r² distance as one, the longer the distance, it falls off as 1/r to the power of 2, so 1/r². To hold, we don't know, let's say, if it holds, if that gravitational force description holds through all of the universe, let's say. So there are different regimes for different physical processes too. So the universe and also the microcosmos, when you go down to very, very, very tiny scales. And as human beings, as a species of human beings, we are kind of in the middle of this infinite scale, kind of, if one can say that. Let's say, well, not an infinite scale, but rather, the very large universal scales, and then the very tiny virus, scale of nuclei, atoms, quarks. When you start really getting into the gravitons, into the fundamental, building blocks of matter. So we live in this huge reality, and as human beings, our eyes are only, let's say, sensitive to a certain window in that spectrum. And so we require technology, we require telescopes, microscopes to peer beyond that, and also, to smaller scales. So being endowed with imagination, with creativity, with rationality, and also irrationality, emotions, and what have you, that's best left to behavioral scientists and psychologists and people who study humans, neuroscientists, and so forth. We're lucky that we are able to be explorers in our own world, and help to evolve ourselves and technology, hopefully in a way that advances and allows future generations to exist, and to continue making discoveries to benefit everyone on Earth and beyond. Hopefully, we will be a spacefaring civilization that may, colonize Mars and go beyond. And maybe, if I may add, in that stream of thought, that we should also be, when we are expanding and exploring space, we should be respectful to what exists there, because we might not know what forms of life there might be that we might not be aware of. So our space rocks and asteroids that are, just rocks for some, they might harbor life. They might harbor, or the basic building blocks of life. So before they are used as construction blocks, let's say it's an imperative to first carefully examine them as one would an archaeological site, or from antiquity, to make sure that we're not destroying something that is part of our heritage as a species that lives on Earth, which is embedded in our solar system, which is in the bubble of our sun, so inside of our galaxy. And our galaxy is one of 10 to the 23, I think, galaxies, or 10 to the 46 galaxies that exist. I think there are 10 to the 23 stars in our galaxy, and 10 to the 23 galaxies in our universe. That's an estimate. So, basically, for that's, I cannot imagine that. So, we're just conversation, and we're all have our own lives and our own cool work and what we do, and yet, we're also in this larger frame where we're kind of insignificant too, but also, of course,
Yes, sure.
where we are also very significant. So it's an interesting reality. So that answer your question. Realities that we live in at the same time, and it's maybe a matter of, it's kind of an onion, or I don't know, like a matryoshka, or what have you. That there are many realities that are simultaneous, and of course, it's not necessary to be aware of all realities at the same time. That can be very confusing, let's say. But it's good to be aware of these things, because that can bring us closer together as human beings. That we have a common heritage, as a life form that started on this planet due
Mm.
to the culmination of many factors that occurred. So
I think that what you just said is I think that this episode will call awesome. I think that I've always thought about things, how to get uh, the episodes to show the name, show what happened to me when I was listening to the one that I'm interviewing, and that's because yesterday I was kind of making some research and understanding what an astrophysicist do and etc. And I got to the question that what is reality, and as you mentioned right now, and also I'm kind of obsessed with this question that are we living in a simulation and how that mixes with reality. Do you astrophysicists get in touch with that I don't know if problem, question, or doubt about uh, what is reality, and are we living really in a simulation due to all the things that you've said?
Thomas, that's very cool that you and your listeners also have are thinking about these deep questions. And say, well, from my opinion, and of course this is just an opinion of one scientist, related, I think, to the topic of consciousness and
Mm-hmm.
how, let's say, maybe there are theories which I don't really know deeply about, that are like about quantum entanglement, about or how reality is formed, within our brains, and how, I mean, it's a very complicated process of how our eyes perceive light, and it's an upside down image because that's the real image. The brain flips that image in our brain. We process images, we process sounds, smell, touch, everything for the five senses, and we form a picture of reality. Also, depth perception. Some people don't have a sense of depth. Some people are colorblind. Some people are blind. I mean, and yet, everyone is able to ascertain a common reality. Some people can see more colors than they have an extra cone in their eyes, they can see a lot more shades of color than let's say a general human can. So it's like a superpower in a way.
Mm-hmm.
Genetic variations as well. I mean, but human beings, and yet there also can be interesting differences, personality, but also to our very own bodies. And one remark, as Carl Sagan would like to say, the iron in our blood comes from the stars. So we can thank the universe for our existence, because the iron that is synthesized within stars, and then when those stars explode in supernovae, they release that iron, and there's like a large recycling system that happens. These gases coalesce, they grow, they ignite, you get a star. That star starts to, it's a nuclear reactor in space. It starts to burn, from hydrogen, then helium, starts moving up the periodic table. Once it reaches iron, it stops. It cannot burn iron. So then it can collapse into, to form a black hole. In a supernova, there are different types of supernovae. And so there are different processes in which the star again releases what it's what it's composed of, or what it's made inside of its factory. Let's say it's a factory,
Mm-hmm.
and we are composed of that. So we sense to stars, let's say, or the sun, which also provides heat and light and is able to sustain life on Earth. To your question. I think, for instance, an astrophysicist per se doesn't work directly on questions to do with reality. Cosmologists may overlap with this because there are also, and as well as people that work on quantum field theory, that has overlap with cosmology. For instance, there are theories about the multiverse. There are theories about universes existing and colliding, but in higher dimensions. So those collisions we would never feel because they are in dimensions which are outside of our perception. So we would never know. So that's more kind of esoteric questions about
Yeah, sure.
about reality. Also, wormholes, for instance, like or rips in space time, as Kip Thorne or Stephen Hawking, would talk about singularities. What's on the astrophysics? Time is not a separate entity, but rather it's part of space time. So space and time are part of a four-dimensional framework. So 3 dimensions of space and 1 of time. That's general relativity. Einstein, for instance, special relativity and general relativity. That also, a lot of thought about reality. Like twin paradox. 2 twins, one staying on Earth, one going to space because of acceleration.
Yes.
That twin has aged less, or acceleration actually would speed up aging, I think. But there is this time paradox where, as one sees in the Interstellar movie, where the person waiting.
Great movie.
Absolutely.
I understood like 70% or less, but it's a great movie. Great movie.
Yeah, absolutely. And Kip Thorne, I think, was So that's great. Perhaps we could encourage our listeners to see it. It's a very very wonderful movie, and there's a lot of physics and general relativity in there. And Kip Thorne, who I think was consulted to advise the director of the movie. He's one of the fathers of relativity, or a lot of these new developments in general relativity. And a great pleasure to have a photo with him from 2002, but when I was a young bachelor student, just the first year, and I was lucky enough that he came to Rensselaer to Polytechnic Institute to give a talk. And there's a scene where 2 of the crew go to the planet, and this is very close to a black hole, and they spend
Yes.
they spend maybe, I don't know, half an hour, or it's a short time, but when they return, they see that their crew member, or rather when they're communicating with the crew member, it's seen that he actually has aged 20 years. By 20 years he's much older. And indeed, like, if one takes atomic clocks and has an atomic clock here, and then flies an atomic clock, on a jet airplane, and its altitude above the Earth, that clock will run slower, I believe. But there will be a difference.
Yes.
Strong, but there will be a difference. So there will be a difference in time. The clock will run a bit slower. In the higher one is in the gravitational well. I think that sorry that part is wrong, but there will be a difference in time. Relativistic equations which describe as one approaches the speed of light, the length, you have length dilation, you have change in mass as well. So mass starts to decrease. So a particle traveling close to the speed of light will approach zero mass. Frame of the traveling particle, everything will start coming to a still. When one has, let's say, these energetic particles that enter the atmosphere, like cosmic rays or other energetic, and then in the frame of reference of these particles, kind of persists longer in their frame of reference than, let's say, an observer watching them. To, let's say, special relativity, about reality, as you asked, like, let's say there's this famous example when a person is on a train and they're throwing a ball while the train is moving. And you just throw a ball, it comes back to your hand. So it just goes up and comes down. But someone viewing the moving train with the person in it will see the ball make an arc rather than just going up and down, because the train is also moving with the person. So, so instead of just this motion, the train, the ball has actually translated down. So it's describing it's the same laws of physics. So you would be able to describe, the velocity, the where the ball lands, how long it takes, but let's say the trajectory for two different viewers will look different. But the laws of physics are the same. So it's this frame of reference in physics that's used to describe things. And this comes in play when one starts to approach speeds of light that are non-Newtonian, so fractions of the speed of light, because the speed of light is the fastest, so 3 times 10 to the 8 meters per second, or 300 million kilometers per second, is the speed limit of the universe. So no information can propagate faster than that.
Up until now, yes. So that's what or is that something that will never change?
Given that goes back to like theories and laws, and so the theory of general relativity, the theory of special relativity, that we have presently, that is a hard limit. So you could have, let's say, the phase. Well, this is a bit technical, but kind of you have kind of but some, like, not information can travel faster, but certain, or things, let's say, signals can appear to travel faster, but actually when you calibrate back to the correct frames, then it will not exceed the speed of light. So it is a hard limit. Let's say...
is that like... does the Higgs boson has something to do with that?
Question. Is a bit limited, so I cannot speak on many things. Many things. Let's say the Higgs boson. People were looking for it because it was theorized to exist at a certain energy, and the standard model of cosmology, or the standard model of particle physics, given different string theories, you can predict the existence of different particles that you would expect given the theory. So the Higgs theory was proven correct. So the Higgs particle, I think, was discovered. Correct. I think the Higgs particle was discovered at the predicted energy. I hope I'm not mistaken about this, but I'm pretty sure this is correct. But just going back to, so you mentioned the Higgs particle, so I think you are mentioning like particles, and these particles, let's say, also in different string theories, they're predicted. You also have entanglement, which is also kind of particles share a similar state, and then their distance, they can be separated by a very large distance. And it would seem that a change in the property of a particle here would immediately result in one knowing the properties of that particle. But that wouldn't involve any signal propagation between them. Let's say string theories, where when the universe, went in this during the inflationary period, where there was a superluminal expansion. If I recall correctly, I think that it's possible that given the properties of the universe at that time, light at the same speed, but the expansion of the universe would have exceeded that speed.
Mhm.
There are things that I don't remember that well now, so I don't want to do it.
But no, don't worry. The thing is that why I ask you or try to relate with the, because it's some things that we've heard, but in that matter, um, how how um, how all the things that Einstein and Higgs or the other guys that have things think about all this stuff, and how is the sun part of this weird, for me, weird thing that is called the universe and the galaxy, how we end up in with all that we've discussed up until now, or how we end up in a planet. I don't know if this is topics from the astrophysicist perspective. You can tell me that if I'm very far away from what you do. It's also important for me to know. But how we end up in this, you studying the sun, and how it will influence our way of living. So I don't know if I don't know. I'm trying to convey what I'm thinking, but the thing is that is how
Right.
this just happened.
So you're addressing basically, I think, the question of the, of reality, like that many things are related, and field of astrophysics, it can focus on, let's say, even looking at the sun, it can focus on the particle physics nature of the sun. It can focus on the plasma nature of the sun. It can focus on, let's say, the waves that you have, because you have also like something that's analogous to earthquakes. So you can study seismic activity, and also like different wave modes, as if when you would hit a drum, or like a bell, or something that vibrates. There are some modes. So the sun has modes, the earth has modes. So you can listen to those modes, and that can tell you things, let's say, on the opposite side of the sun that we can't see, because the sun takes between 25 and 29 days, let's say, roughly to rotate fully, to make a full rotation. And during half the time we don't know what's on the other side, right? So there are different aspects.
Sorry, in that mode, or if I understand correctly, it's sort of a vibration. It's like a frequency in which. So, are we in sync, like the Earth and the Sun are in sync in that mode?
Good question. So there isn't like a syncing of vibration modes between the Earth and the Sun. But I mean, you can, in a laboratory, have objects that you can, let's say, the resonance. You can bring them into resonance, or like when playing a piano, you can, when you hit a string, you can have one octave and another octave, and they can be fractions of a sound, right? So systems like that. But there is not this resonance between the Earth and the Sun. This resonance does exist, let's say, between Saturn and its moons. So you have resonances in terms of periods of rotation of the moon around Saturn. So affects, as you correctly said, but it's just not between the sun and the Earth, but between planets and their moons that this can happen. And this has been observed. It's a very cool question. There's a lot of overlap between different fields. It's not like astrophysics is a standalone field, but it benefits greatly from, let's say, particle physicists like Higgs, or discoveries in high energy physics, electromagnetism. A lot of the sun's main activities are driven by magnetism, by the magnetic field, and to understand the measurements, to understand, let's say, of galaxies, or one needs to understand how the signal is polarized. The signal has a certain orientation as well. Like on sunglasses, you put on sunglasses, you see much clearer because the random scattering of light, that doesn't pass through the filter, but the filter only passes through a signal that is aligned with the filter itself. You have multi-physics. You have a lot of different spatial and temporal scales that are at work. They each have their own different physics and different phenomena, so that's all tied together. So as an astrophysicist, one needs to kind of choose a problem or several that one wants to work on. So in order to have to focus on one question, let's say, or several questions, because there are always so many questions, and
I wouldn't been able to I wouldn't have been able to do that. I think that the thing is that as you speak, I'm kind of wondering if this happened, I should study this, I will study that. How can you pick from all these interesting problems?
That's a great question. It's easy to think of this as very complicated and to get lost in the jungle. So it sounds like just a jungle, but and it is. But let's say if you've studied botany, then you're not afraid of the jungle, because you can say, "Oh, I know that plant. Okay, I know that. Oh, I don't know that plant, but I can name it because I see how it's related to other plants, or maybe it's a completely new species." Okay, I see how this vegetation, how they interact, how this plant keeps away predators that might eat it, or maybe they are mammals or other animals or birds. It has fruit and it pollinates by attracting this insect. So you can begin to study the ecosystem. So there's an ecosystem in the universe as well. So there's an analogy, let's say, to the jungle ecosystem. And by studying like fundamentals, like STEM, like science, mathematics, physics, biology, chemistry, one can focus more on what is more interesting for a specific person, based on their personality, based on their interests, based on their curiosity, and start to focus on that. And that have their favorite star or their favorite galaxy, and they dedicate their life to studying that. Some others search for life in the universe, signals of life. Others look at space weather, to see, what is the effect on, to give a warning for possible effects on modern technology. So some are more applied, and some are more theoretical. Some are more based on models and theories. Others are based on data. So, you have instruments that collect data, and that data is noisy. It contains a lot of influences of different physical forces, of different environments. So, let's say one needs, or now AI, artificial intelligence, is being used, like machine learning, deep learning is used to find patterns in that complex data, because theories have gotten us far, but still there is still a ways to go. So it's good to combine theories and data to see what complexities can be further understood, or what patterns can emerge. So yes,
I'm a huge fan of Apollo 13, the movie. I'm a fan of. I'm very curious about space. You told at the beginning that you focus on space weather. I imagine how that influenced, for example, what happened in the ISS. I think it's kind of your field. Or how is space weather related or analogy to the weather in the Earth? How is the weather studied? Is like similar, or is another way of approaching it?
That's cool. So indeed, the ISS, the influence is definitely from space weather, from the sun. So you have radiation. So these energetic particles that are coming off, that's the radiation that we're getting. And of course, during, let's say, a magnetized cloud called the coronal mass ejection or a solar flare, those are very energetic particles with a lot of energy. And when that cloud or that solar flare, those particles, they can really harm life. So it's a large dose of radiation. So let's say astronauts would need to remain inside of the ISS and not go for a spacewalk because their shielding might not be enough to protect them from such a radiation. So that's why it's also necessary, let's say, to monitor the sun. And just like terrestrial weather is monitored by satellites that orbit the Earth and observe the Earth at different frequencies, they are sensitive to water vapor. They can measure the electric field of the Earth. They can measure the wind velocities at different latitudes, gases that are emitted. So they can model, what's happening. They can track hurricanes. They can track different weather patterns, sea patterns, pollution, global warming, temperature increase, how that affects the climate, ice melting. So the similar way that that these instruments look down upon the Earth, you also have dedicated satellites that orbit the Earth different orbits that observe the sun continuously. And you have also, let's say, like a solar orbiter or Parker Solar Probe that are the closest man-made objects to ever come to the sun. So they're extremely close to the sun. They have very clever engineering in order to keep them cool and not melting. That's a very cool engineering masterpieces that can survive being so close to the sun. High resolution images and readings to understand the different phenomena that occur at different scales. So different,
Sorry,
Yeah.
just
Sure.
just one question.
Yeah.
I was thinking about the Icarus myth, and it's very weird because when you get in Earth, as you get closer to the sun, you start freezing, but then outside space, as you get close to the sun, you start melting. So that is, I was thinking about that, and as you told about the physics of this kind of space robotics, where you have to have a cooling system that is awesome, because if not, everything is melted in the sun.
Bringing up the Icarus, I think that also like to propose names of missions, and many missions have mythological names. There was this, even moons, let's say, have mythological names. Even planets, Jupiter, Saturn. Those are the Roman names, for Zeus and Poseidon. So Jupiter is, I think, Zeus, and Saturn is Poseidon. You have mission names that are one mission that was proposed that unfortunately wasn't funded to completion because there was not enough. This, I think, was the son of Icarus. So one has this wealth of mythology that was created, and that's very, very, very alive and very well and used. And also, I think Shakespeare's characters as well are used in the names of some of Saturn's moons too. You mentioned these very big temperature differences, and this that the fact that as one goes to higher latitudes on Earth, it becomes very cold, and because of dissipation of heat, heat is not. So heat is very well preserved by the water. So water has the great capacity to keep heat the longest of any other material here on Earth. So, like for instance, on the moon, as in space, you have indirect sunlight areas that would reach, to become hundreds of degrees, basically melting. And at the same
Mm.
time, you have, let's say, permanently shadowed regions and craters on the moon where the temperature would be extremely cold, so things would freeze immediately. So you have these very wide temperature contrasts. Also, in space, when there's shielding on the ISS, so that one doesn't look
Mm.
directly at the sun because one isn't protected by the Earth's atmosphere anymore. So the Earth's atmosphere is very good at keeping at let's say prevent already stopping UV, gamma, all these very energetic radiation that is coming. So that's why it's dangerous. So there's an ozone hole, right? And hole in the ozone
Mm.
is very effective at absorbing UV. But if it's not there, then that UV is able to reach to lower latitudes and actually, affect humans, cause melanoma or cancers. So it's all radiation. That's what we call radiation. These different particles with different energies. Some of them are too low to cause harm, but many are very energetic. So if they hit the skin, they will dissipate a lot of energy, and that energy might damage cells and disturb normal cell function, which would cause.
We are constantly bombarded by by particles, as I'm understanding
Yes,
now.
yes, like exactly. So, but one interesting point, like just to about this kind of paradox that you were alluding to, between simultaneously having hot and cold and very hot temperatures. Like when one has this giant magnetized cloud that is launched from the sun and affects the Earth, while affecting the Earth, it also blocks galactic cosmic rays, which are coming outside the galaxy, which are extremely energetic particles. So this cloud, while raining down on Earth, also deflects those particles. So yeah, it's an interesting that this kind of duality that one
Mm.
has of physical processes. That
So I have a lot of questions, and I don't know how are you in regarding time. I don't know if we can extend some more minutes
Yeah,
in
sure.
order for me
Make it
to
fast.
ask you. Yes. So the question that arises now, as you I think it's impossible for me, as you said at the beginning, to to leave kind of the philosophical questions regarding of what could have happened to you while studying this. So in this way, it seems that everything is so perfectly built and etc. That the question that of course arises is like, do you believe that this is something? Do you believe in God, in something that made this, or this is pure chance, or is a mix of things? Because, as you said, the sun bombard the earth with a lot of particles, heat, etc. But it protects also from other particles that come from uh, other galaxies. So this kind of thing tends to, or seems like it's so in sync and so perfect that what did it or was designed. What is the discussion in the field?
For this philosophical question. Indeed, I mean, there are scientists also looking for signatures of life. There are instruments, even there's a life mission, it's called, it looks at light from the host star that passes through the atmosphere of exoplanets and then gives signatures of what kind of chemistry exists in those atmospheres. So if we see, let's say, that there's a lot of methane or things that we as humans have produced that weren't there, then we could start to hypothesize that maybe there is a civilization that is also burning wood or using up,
Mm.
producing fossil fuels or producing methane, because like cows produce a lot of methane, we produce methane, and that's kind of a common biosignature. So in the book of Michio Kaku, he talks about different, and I think also before, there are different stages of civilizations. People starting with civilizations that are kind of at the mercy of their worlds or the environment they found themselves in, to civilizations that can do engineering on the scale of their planets, even shift their planets, fly their planets to other stars when their host star is becoming too big. For instance, in many millions of years, our own star, our own sun, will become more red and will become much bigger. It will swallow Mercury and Venus, and expands quite a lot. So, at that time, I would
That will happen now,
no,
or
no, in
in
millions of, no, 10 million, no,
like,
no, in 10 million years. I mean, it's far, far in the future. Like we have tectonic plate movement, which causes earthquakes as well. All these mountains. Very recently, about how many extinction events took place on Earth, and how the chemistry from the fractioning supercontinent that existed before, where all the continents were together,
Mhm.
how the separation of those continents introduced a lot of phosphorus into the water, increasing the speed at which life in the seas grew, but also at the same time contributing to a large pileup of organic matter at the bottom of those seas, which we now see in terms of fossil fuel reserves for oil. And because of that crazy kind of, it's like adding fertilizer to flowers all the time and seeing like supernature, like seeing flowers just become crazily huge, like that happened with the sea life. And because of this crazy amount of life that was there, and it, dying and sinking to the bottom, that created too much, that trapped too much oxygen also, and so depleted the ocean of oxygen, causing them to become anoxic, and therefore getting rid of actually all life that existed, basically. So there have been many extinction events in the past, and thankfully a small percentage of animals and life had survived in order to allow us as humans to evolve from that. So this just to show that at the same time that you have, let's say, Earth as Gaia, as the nurturing mother, or the universe as a nurturing universe, you also have at the same time a very inhospitable planet or a very inhospitable universe. So some things can be conceived as being almost perfect, or like, wow, we have an atmosphere and we have conditions that allow us as humans to exist on Earth. But that is due to many, many factors. It's also, it's something to be grateful for, that we are able to exist as humans and as a species, and hopefully to be good custodians and to preserve and make sure that we as a species can continue in good health and for future generations. In the view of these civilizations, let's say, that have been postulated, right, like by Michio Kaku or by others, then you would have, let's say, very advanced civilizations that live toward the center of the galaxy, where when they look out from their planet, maybe they see three suns in the sky, or they see, along with many moons around, right? So they can have beautiful views that for us as humans is hard to imagine, right? Like Carl Sagan writes about instead of the moon rise, but the Earth rise. So astronauts on the moon would see the Earth rise rather than the moon rise. So, you have binary star systems, triple star systems. When someone on the planet would see three suns in the sky, of different color. That's amazing, right? I mean,
Amazing.
that's a cool view, right? I mean, different sizes too, right? So a very big sun, a small sun. And triple star systems are unstable. So eventually, after millions of years, one of those suns will be like a billiard ball ejected at a hypervelocity. So that sun will just go flying at a random trajectory through the universe. So, and that sun could have a solar system around it, So that solar system could be like a speck of dust, just flying along, like in the movie Horton Hears a Hoot from Dr. Seuss, which was I thought a brilliant
Mhm.
movie. I don't know if maybe perhaps your viewers have seen it. There were this different Dr. Seuss movies, and there's one with Horton Hears a Hoot, and that's because Horton the elephant he hears
Horton is the
the
elephant.
elephant.
Yes,
Yes,
I watched it in yes, that was Jim Carrey. I think that the elephant was.
could be. That perhaps yes. Like there was the Grinch. That Stole Christmas. That's another Dr. Seuss. So this Dr. Seuss, Horton Hears a Hoot, because Horton hears what he thinks is sound coming from a speck of dust. And no one
Mm.
believes him. They think he's crazy. They try to burn that speck of dust. They try to imprison him. They try to, like make sure none of the kangaroo kids or anyone else hears what he's saying because they think he's a mad person. But in the end, he's able to prove to everyone that actually, by constructing an instrument, hear a peep, like a hoot from Whoville,
Mm.
which is the society, the civilization that lives on that speck of dust. So that's a very interesting film because, in a sense, one could think, let's say, of a hypervelocity star that has a solar system around it as being that speck of dust that is flying through the universe.
Mm.
Also, coming back to Earth, I think from the 20s or 30s, or maybe in the mid 40s, was the first transmitted signal into space. And we've been transmitting even before we knew that our radio signals were being transmitted to far beyond the Earth. So there could be someone, perhaps listening out there, maybe, someone who's also using our host star to study the atmosphere of our Earth and seeing, oh, wait, there's a lot of methane there. Maybe it's worth to investigate. Maybe there's creatures there that are worth investigating, or not, because the Earth is kind of far away in a dusty arm of one of these spiral arms of the Milky Way. It's very far away
Mm.
from the center. Kind
Oh.
of, one could argue also not in a very interesting place to go and kind of far out of the way from the center. But also, we live in an interesting place. It's not an ordinary place either. So I think that um, it's kind of human nature too to put ourselves as special or on a pedestal. But it's important to step back and look and say, hey, we're also one of a species of countless
Mm.
other species on Earth, ones that we even haven't discovered, ones that we might not know coexist with us as well. Certain
Mm.
species that in the Amazon or wherever, under the water, under the oceans, there are hidden oceans that were discovered in places within the Earth that we didn't know about. So maybe there are 80,000 leagues under the sea, or Journey to the Center of the
Yes.
Earth that he wrote about. That maybe there are worlds, or like in the Indiana Jones movie, I think the last one, where they wind up under the Earth and they see actually a prehistoric, still continuing existence. So there are other existences that can coexist that we're not simply aware of, and we think we've moved on. Just like there are also human societies on Earth, tribes that we've never met
Mm.
that still exist, that continue to use technologies from thousands of years ago, and they're not aware of us either, because unless they happen to have seen a plane, or and they live in their own reality with us at the same time, but yet those realities are separate. So reality, going back to our start of the conversation, is so diverse, so complicated that certainly there are, let's say, there is intelligence, but that intelligence is also kind of beyond our understanding, and our mind, I think, would like to map it to something that we can understand, that is something human or
Mm.
something that uses a brain. But what if it's something that
Mm.
doesn't have a brain, that doesn't use carbon to think, that maybe even thought is not thought, but something else? We don't know. So talking, people think of the universe as having a beginning and an end. Because that actually there's this complicated geometric structure which doesn't have a so-called beginning or end, and that's mind-blowing for humans who are used to having a start and a finish.
Sure. Yes.
So, and also, for instance, maybe another movie reference, if we can, like The Arrival. which was also a movie that I think was quite cool. Language that is kind of
Mm.
more than language.
Yes, I think. Sorry, I think that language is kind of a compression algorithm to like
Mhm.
to kind of map reality, but it isn't reality itself. So that's why in that arrival you have. I remember there were kind of spots that
Mhm.
they tend
Yes.
to. Okay.
Yes, yes, oh, yes, exactly as you said. Right, mapping reality, and indeed, like what science and languages and all of, well, most of human endeavors try to map reality onto something that we can understand, and it's always an approximation of reality. A model
Mm.
is only as good as the model is. Like it's only as good as what it can predict. No model is perfect. No, like
Mm.
now, but no model is perfect, but like no model is perfect, but all models are useful. I think that's something like that.
Hmm.
So all models are useful for something. You can get some approximation. Maybe it's very crude. Maybe it tells you very little, but it tells you something. Like mythology, also mythology is trying to map reality onto
Mm.
what understanding, right?
In a different, yes, in a different way. Yes,
In a
sure.
different way, exactly. Like looking up, the ancients, and we see stars, and they construct patterns in that. So they think, oh, this is this event. Astrology is a pseudoscience. So I will not
Hmm.
talk about it in science, but astrologers, they try to map reality also. They try to figure out, oh,
Mm.
the alignment of the stars, oh, must be an influence on humans to guide the behavior. Oracles try to predict the future. That's why they were kept, to define reality and try to, of course, the big $1 million or $1 billion question is, see the future with these
Mm.
things. I mean, there exists, let's say there are infinite possibilities, right? But there is also um, like um ways that are, as a, my supervisor, one of my supervisors like to say that it's good to keep to your pocket, that you don't lose your common sense, because common sense, as
Mm.
another person said, is not so common. So
Mm.
although one can think of anything, one can imagine any reality, but that doesn't mean that all these realities exist. Just like there are so many string theories that are made, but it's for the experiments to show what is actually real and what isn't. So it's perfectly fine to imagine and to create myths and to try to make sense of the world we live in. That's wonderful. That's exactly what brings progress to humanity. Another thing is to also update our views to reflect what we know is real, what we
Mm.
think might be real, and what we might not know of also. So there are things that we don't know. There are things
Mhm.
we do know that we don't know. There are things we know, and there are things that we know are not real, right? So also balance, and of course, belief. People are very welcome to believe. Of course, that's also human nature to believe in things, and like science is a path to establish what is real. Like, and science is, it's different to play with words and say, oh, we believe this is true. That's just playing with words. Science finds evidence for to concretely justify and make sense of, in terms of physics, chemistry, biology, mathematics, in terms of the knowledge that we have, that we know is knowledge, that we can use to build technology, that has been tested. All these
Mm.
failings to launch, Starship, are needed
Mm.
in order to make the technology work, in order to understand what works and what doesn't. Because if the engineers will think, oh, we can do anything, and
Yeah,
anything that
sure.
we do will work, no, obviously not. Architect, as an engineer, as anyone who builds anything, as a construction worker, as someone laying the cement in the ground, I mean, they know their trade, because that body of knowledge, it is a body of knowledge. It's not that they believe it will work. They know it will because it is evidenced by their experience and by the experience of those who have tried and tested, have failed before to make the perfect cement, have failed to make the perfect building, have failed to launch the rocket. That's great, because on that failure was built the formula for success. And so that body of knowledge is used to arrive at further bodies of knowledge. And that's very useful because that guides us to further bodies of knowledge. That is like a river flowing to an ocean. If we say, oh, this river doesn't flow anywhere and we're gonna leave the river and walk some random path through the forest, well, good luck finding the ocean. Maybe you will, but maybe following the river is a better course, because that will take you to an ocean.
It's a balance between pragmatism and I think that what you're saying is, or what I interpret is that it's a balance between pragmatism and belief, because you need to believe in something in order to study it, but you need pragmatism in order to get to the point where you said, no, this is not real, let's get to the next topic.
Yes, and belief, belief also inspires. Like, for instance, I think the famous Indian mathematician, I think I mispronounced his name, sorry for that, but I think Ramanujan, he was an Indian, very gifted Indian mathematician who developed an entire new branch of mathematics by himself, just autodidact, just self-taught, I think. He was invited to Cambridge, but he died, and he was always used to living in his village, and the journey over the sea, taking the boat, was too much for him. So I think he passed away because of that big change. But he achieved an amazing mathematician, and he was inspired by the Hindu myths, by the Hindu gods, because he believed, in all of these mythical stories, and that kind of inspired him to kind of, because you need kind of these also these perturbations on reality in our quest, kind of in our adventure to understand reality. One has these stories, these narratives, which are quite powerful, and they are inspiring, and they cause people to not kind of to fall asleep to the mundane, just the rhythmic, oh, I know everything already, there's nothing more, okay, I'm just gonna keep repeating what I know, and that's it, and that's all. Like, hey, actually there is more, there is much more, and even more than that, and oh, I don't even know how much. So that quest, that kind of knowing that there is more is exciting, and I think drives people to step out of their comfort zone, to step out of their shell, and be like, hey, actually, well, I might not know this yet, but let me see how far I can go. Let me push the boundaries of my own knowledge, of my own understanding. Let me be open to reevaluate my knowledge or my beliefs or my understanding, and let's see, perhaps I can even discover something new, and contribute to human knowledge, and contribute to human knowledge in very diverse ways, or contribute to the building of to knowledge in a sense.
That's a great segue to ask you. I think that it would be the final question of this episode. I'm a fan of a podcast that is called the Lex Friedman podcast. It has rounds, round 1, round 2, round 3 with another with the person that he meets. So I'm fascinated with what you've had what we have discussed. So I will like to ask you if we can meet again in a couple of months, maybe, and in order for me to also understand everything that you have told me. But I think that there is one thing that I was reading about what you did, and I didn't understand. So I wanted to ask you, what is pangenomics? Because you told about knowledge and how you want to, and what I understood about what I've read is that pangenomics is something very far away from your field,
Yes.
or not?
Yes, indeed. Well, many overlapping areas. Yes, it is very far away from the field, but in kind of the loose way that everything is connected. That the iron in our blood comes from stars. In that way, actually, there is a connection, but kind of a very fundamental, kind of very very far removed connection. Let's say. Looking at, let's say, the genetics, looking at how to enable people to sleep long on long duration space flights to Mars, let's say. How do we keep people in a state where their body is healthy, they're functioning, but they're able to sleep for many months or years? Like there's a cool movie, I forgot the name of it now, with the actress who played in Hunger Games, and it's a starship which I think needs like 90 years to get to the next habitable place, and everyone is asleep until one mishap happens. So this main character, one of the protagonists, wakes up, and he wakes this actress up, and then there's a very interesting story. So we need artists and movie producers who who see ahead, who like already show us that this might be a possibility in the future someday, like Star Trek or other interesting or the movies we've discussed. But how do we actually enable this technology to exist and to allow for human beings to really become a spacefaring civilization, like we were also discussing? And I think I remember reading some time ago about a young woman scientist who saw this mammal in Canada, I think, which is like a rodent who has a very interesting way that they can sleep for a very long time. They can hibernate for months, and they basically don't need to eat anything. They're able to sustain themselves, just wake up and then function again. And just to go on the side a bit, creatures are very amazing. I mean, there are like lizards that can lose their tail when they fly, and then they can regrow it back. We cannot regrow limbs back by ourselves. That's dolphins can use sonar. We cannot. We don't have that technology. Innately. There are like the meerkats, when they go with poisonous, venomous snakes, they get bitten. That poison would kill anyone else, but they're able to completely shut down their heart, and basically, as if they're dead. But then after some minutes, they restart again. I mean, wow, that's amazing, right? Like, antivenom is derived from horses, because horses are animals that are able to naturally resist venomous bites from snakes, right? So that's cool, right? They have that antivenom. We don't. We would be already worms in Chernobyl that have been bombarded by such radiation that any other life form would already be destroyed. But those worms have such a loose DNA that although their entire function is destroyed, they're able to move this DNA around and then again, like be reborn as another kind of worm, but the same worm that was just dead. So there are very interesting things that are there already, like spiders that can. I mean, spider webs are something that is an amazing structure because that is so light but yet so strong. And people use, there have been genetic experiments where they have used genes from spiders and put them into, other animals to try to create some extremely strong but very light material. Because spiders, they're like parachutists. They create this web and then the wind picks it up and they're like parachutists flying across countries and continents. I mean, that's amazing, right? I mean, a spider.
Yes.
Who would think? Ants can make a vacuum under their legs and then support masses on themselves that are many times their body weight. Wow. And being upside down at the same time. That's incredible. They can build cities underground with very profound highways and tunnels. Ants, right? I mean, and that's because they're able to communicate to each other very well. Also, bees are able to see polarized light. They dance to each other how to get to certain flowers. Plants can sense predators. They spray chemicals. Bacteria some of the first users of very primitive language. Even the bacteria that come and invade us make us feel bad. First, a few bacteria arrive, but then they signal each other with specific chemical signatures to tell, like, hey, I'm here. Then they hear an echo back, oh, I'm also here. When enough echo back, then they start to invade. But they wait. So they have this primitive language exchange, right? So you have a lot of very fascinating things that we as humans have a lot to learn from. And that's just, a very tiny thing. Back to your question, pangenomics, yes. So as a scientist, as someone who is curious about reality, I was curious to look at the field of genetics and about cancer research and to see how mathematics and physics can be used to address cancer research. This is a very fascinating workshop, which looked into the causes of cancer. And then, in fact, I also did a postdoc in bioinformatics looking at the cancer genomics and machine learning. And, the body itself, it's a very fascinating, vehicle, a contraption, a body, a vocal instrument for people who sing. Our DNA works, how our genes work. The evolution that we go through when we're born, when we're conceived, to a baby, to an adult, how we age, how people are now working to let people live longer. People now, given the very sophisticated blood analysis that can be done by knowing more about methylation of the DNA, people take supplements, and people can really reverse themselves 20 years or more, and their biological age is 20 years younger. Wow, that's really cool. Because there are communities around the world with people living to more than 100, very healthy, and they're in China, in India, in Greece, in South America. I mean, all over the world, you have communities of people who live very old, and it's like, wow, okay, so people can live very old. Why? How do we do that? So there's a lot of interesting developments everywhere. I would say, our own biology, the future of what it means to be human. In the future, people envision humans merging with chips or being enhanced
by chips, AI.
Yeah, AI, also enhancements. I mean, people who have suffered grave injuries that cannot move. I mean, they're able to move with the motion of their eyes, or they're able to communicate. Their brain is able to send signals to their muscles because of implants or because of a certain exoskeleton that has been put on them. There are developments in exoskeleton technology where people can transport enormous masses just through having, the Matrix, kind of in the Matrix movie. You see these them getting into these machines, these exoskeletons, and firing at these robots that are coming. So that's under developments. I mean, there are strides made in every direction. I mean, new materials for building, for mega structures like in Norway, with this underwater rail systems, or new cities that emerge in the Far East, in China, in Dubai, and I don't know, in the Middle Eastern countries. You have very futuristic cities and almost zero pollution. They're very cool. I mean, and that again takes people who have the basics of basic science, that are driven by passion, who are interested, and who want to make a positive difference in the world. And they're like, okay, I want to be an architect, I want to be an engineer, I want to be a physicist, I want to be an astronaut, a firefighter, a doctor, whatever profession. I mean, and then they make their contribution, and that together serves everyone. So yeah, sorry for that again. Long.
No. That's due to time,
Yeah,
of course,
excellent.
that you that you have. I will continue. Uh, if it wasn't for my for that I
Thank you. Thank
I
you for
will
being
talk.
awesome.
I will talk. No. I will talk with you like forever, because it's very interesting what you've told me, and it's also what I told Carla in. I was joking with her, and I told you that I think that your conversations would be so intelligent, because both of you are very intelligent and uh, very passionate about what you do. I
And I learned a lot from Carla. So yeah. So
Yes, yes, yes. She's a great. We talk about with her. We talk about the possible adjacent, and I think that is a very interesting topic, and that's the name of the episode
okay.
for her episode. So um, I really thank you for the time and this hour and a half that we have. I really thank you for making time in your agenda. I know that uh, I have a lot of questions that I will ask you, and in the future, in if you are of also available to do a second interview, it would be awesome for me to have you again.
Thank you, Thomas.
And also, it's been quite a great experience for me to write to people that I don't know and ask them to for interviews, and everyone has been so nice. I think that everyone that is passionate about what he does or do uh, is available to talk about it. So
Well,
I
that starts
really
from you.
thank you.
Thank you, Thomas. That starts from you because your passion. You created this podcast. You dedicate your time. You woke up at 4:30 this morning. That's wow, man. That's incredible dedication. And your podcast allows women and men and individual to listen and learn about new things that yeah be inspiring for them, hopefully, like
Hmm.
or they might see something that might be like, oh, that's interesting, I never didn't think about that way maybe. So
That's the purpose of this. So thank you very much.